Hey everyone, I wanted to show you a new Agda feature that will be helpful on your homework that we didn't get to in class. So I've got some standard imports here, got the natural numbers, booleans, lists, and here's just a function to test if a natural number is even that we wrote before. We'll use that in an example later. So I want to write a filter function. So this is just like the standard filter function in Haskell. So for all types A, we're going to take a predicate, right, that says give me an A and I'll tell you a Boolean, and then we're going to take a list of A's and output a list of A's. And we're just going to keep the A's for which the predicate is true. Okay, so let's try to implement this. So I've got my predicate P and my list X's, and we'll load this. Okay, let's make this a little bigger. Okay, so of course the first thing I want to do is pattern match on the list X's, and if it is empty, then I'm just going to return the empty list. And what do I do if it's not empty? So here's where we're going to use the new feature of Agda. I actually want to check whether the predicate is true on X, right? And if we're writing this in Haskell, we might use a guard or write an if, but Agda doesn't have guards and it doesn't have if. In fact, in Agda, bool is not special at all. What we really want to do is pattern match on the output of px. So when we apply the predicate p to x, we're going to get a Boolean, and we want to pattern match on that Boolean to see if it's true or false. So it's not an argument that I want to pattern match on, it's the output of some function. And the way we can do this is with something called a with clause. So I'm going to get rid of that equals, and I'm going to say with, and then I'm going to put whatever the thing is that I want to pattern match on. So in this case, I want to pattern match on p, the output of px. And I actually don't need the parentheses, but we'll leave them there for now. And then I'm going to put something down here. I put ... which means I keep the same pattern matches from before, and then I put a vertical bar, and then this argument here is going to be the result of pattern matching on px, or the result of px. So then I can put, so now I've got this Boolean called b, which is the result of calling p on x. And I can now pattern match on b just like I would on any other argument. And it expands the ... into the same patterns that I had before. And then after the bar, I get the possibilities for that Boolean. So it's kind of like I'm adding an extra argument to my function, but that argument could be built out of other arguments. So from here on, it's pretty easy. If the predicate returns false, then we're going to output, we're just going to filter x's. And if the predicate is true, then we want to include x. So we'll do x cons filter p x's. Okay, and just to see if this works, we can try, if I do Control-C, Control-N, it lets me type in whatever expression I want. So I could say, filter even, if I say 1, cons 2, cons 3, cons 4, cons 5, empty list, right, I get 2 and 4. So I just kept the even numbers, so that worked. Let's do another example building off a filter that will also make use of this with. So let's define a data type for what it means for one list to be a sublist of another list. So it'll be something like this. So for any type A, this is going to be a it's a relation on two sets, right? When is one set a sublist of another list? Or when is one list a sublist of another list? And so I have to say, what is the evidence for this thing? So first of all, both lists could be empty. It is true that the empty list should be a sublist of the empty list. Also, I'm going to call this one sync. And we're going to say if I've got two lists, x's and y's, and if I know that x's is a sublist of y's, then I can say that if I cons the same thing onto both of them, that those should still be in the sublist relationship. So x cons x's should be a sublist of x cons y's. And I guess I need to add another, for all x. I'm going to make that an implicit argument. Actually, I'm going to make these implicit arguments too, because Agda can definitely figure out what x's and y's are just based on the fact that x's and y's show up in these things over here. Okay, and I called it sync just because the lists sort of sync up at this point. They both have the same thing at the beginning, and then the rest are, the first is a sublist of the second. And the other thing that could happen is that we might skip an element, so the first list might not have an element that the second list has. That would still make it a sublist. So we'll say, again, for any x, and for any x's and y's, if x's is a sublist of y's, this time I'm going to say x's itself is a sublist of x cons y's. Okay, and just as an example, we'll show that, like, let's see, 1 cons 3 cons 4 cons nil is a sublist of 1, 2, 3, 4, 5. And incidentally, to type this sublist thing, you can say, you can write \sub equal. So let's see if we can prove this. Oops. Well, they both start with the number 1, so I want to use the sync constructor first. That works. And then it says, okay, what you have left to prove is that 3, 4 is a sublist of 2, 3, 4, 5. So for that, I'm going to use the skip constructor because the first list doesn't start with 2. So I'm going to skip the 2 in the second list. Now I have to prove that 3, 4 is a sublist of 3, 4, 5, which it is. So I'm going to say sync again for the 3's. I sync one more time for the 4's. I skip the 5. And then I just have nil at the end. Okay, so it looks like that works. So what does this have to do with filter? Well, we should be able to prove that if you filter a list, the list you get as a result is going to be a sublist of the list you started with. So we'll call this filter sublist. So we'll say for any set A, and for any, let's see, well, for any predicate P, and for any list x's, it should be the case that filter px's is a sublist of x's. Let's see if we can prove this. Okay, well, I can certainly start by pattern matching on x's because that's what filter does. So in the empty list case, I just have to prove that the empty list is a subset of itself, which there's a constructor for that. And otherwise, what do I have to do? So notice, if you look at the goal, you see that we have to show that filter P of x cons x's is a sublist of x cons x's, but notice there's this bar here in this px. That means it's actually, in order to reduce further, we have to pattern match on px. So this is coming from that with clause that we did. So we have to do the same thing here. Whether this is true, or the proof that it's true, is going to depend on whether px is true or false. So we need to do a with clause again, the same way we did before. So we'll say with px, dot, dot, dot. I'm going to add my extra parameter. We'll call it b. B just for Boolean. You could call it whatever you want. Okay, and now I can pattern match on b and say, okay, is it true or false? If it is false, that means we do not include x in the filter, and so we're going to skip that x. Right, so if I say skip, right, now I'm left having to prove that filter px's is a sublist of x's, but that's just our induction hypothesis. So I can say filter sublist. For some reason, auto actually doesn't work here. I don't really know why. It totally should, but that's okay. We can do it ourselves. And in fact, auto will work for both of these. So it has to be p, and the list that we're going to use is x's. And then in the true case, we have x on the front of both lists, so we want to use the sync case. And now, again, this is just the induction hypothesis, so we should be able to do this. So there you go. That's an implementation of a simple filter function in Agda. Of course, filter really is in the standard library, but we just implemented it ourselves. And that shows you a simple example of using a with clause in Agda.